Hi guys, now I'm going to be going over 1.8. I do want to quickly just say something. The thing that they are trying to teach you in 1.8 is to use rectangular arrays in order to find out what the answer is and to use the distributive property. And I am not in agreement to what it's trying to teach you. So I'm going to make it a little bit easier to help you. They think that you should just automatically know that 9 goes into this number and you can take 9 out of both numbers, and I totally do not agree. So I'm going to make it easier on you. And I do want to show you some rectangular arrays and what it truly is trying to tell you. And I'm going to try and make it as easier as possible. The thing I'm going to do is, instead of showing you the way that they want you to do, I'm going to tweak it a little bit. So it's going to look a little different, but I'm just trying to make it easier on all of you. And I will show you what it truly is trying to say. It's just a very wordy, not really, I don't like the way it's trying to teach you. So I'm going to adjust it a little bit for you all. So now I'm going to switch it over here so you can go ahead and see what I'm talking about. So I'm going to switch my camera. All right, so here is what it's saying. It says you are going to relate multiplication to division, which is fine because division is opposite of multiplication and multiplication is the opposite of division. So you can use the relationship between multiplication and division to solve a division problem. Using the same numbers, multiplication and division are opposites or inverse operations of each other. So here is just showing you the factor times the factor is the product. So they're giving you 3 times 8 equals 24. Now, it's saying you can check a multiplication problem using the opposite operation, which is division. Just the only thing is, now you can work backwards from it. So they're saying that you could do 24, then you just switch it up. The opposite of multiplication is division. So 24 divided by 3 equals 8. Or you could have said 24 divided by 8 equals 3. So either one of those would have been fine. So just know that the opposite of multiplication is division, and the opposite of division is multiplication. So here is the first problem that I'm going to show you. It says Joel and his 5 friends collect 126 marbles. They share the marbles equally. How many marbles will each person get? So first of all, if you look, it says Joel and 5 friends. So that is a total of 6 people collected that many marbles and then can share them. Well, here is what you should do. And this is nice as well. I will go ahead, and we know that we are going to be taking 126 and divide it by 6 people. So our dividend here is 126. That's how many marbles that we have. And then we have to divide it by its divisor, which is 6, because it's amongst 6 people. So it says over here, underline the dividend. So I am going to underline dividend of 126. And now it says, now we got to find out what the divisor is. Well, I just said that. We're going to be dividing it amongst 6 people. So that is our divisor. So they want you to go ahead and then form an array based off of this. And I am truly not a fan of how they're trying to tell you to do that. My advice to you is to divide it out and find out what the answer is. Now, this is great to do this now, Now again, the first number that they always give you in a division problem always goes in the box. So that is always going to be your dividend. And the second number of your division problem is always going to be your divisor. So this is how it's going to look. Now, very quickly, I like how they put this in here because I do change up the directions on what I want you to do, and which is perfect because next chapter 2 is talking about division. So I could even get you ready for division and show you these steps, and you guys can kind of be ahead of the game for chapter 2. So in division, I do have a crazy saying on how this, what the steps are. It is dead monkeys smell crazy bad. So here are the steps. The steps are the dead, the D in dead stands for divide. The M in monkeys stand for multiplication. The S stands for subtraction. The C stands for check. And the B in bad stands for bring down another number. And then when you bring down a number, you must start again. So that is the steps to it. So I'll be talking out the steps here. Also, again, I said that if you're not knowing your multiplication facts very well, you can use that division chart. So that is why I'm extending it to like 2 to 3 weeks of you guys using this so that you guys can start to learn them. So how you do this is you use those steps: dead, monkeys, smell, crazy, bad. So the first thing you got to do is first see if 6 can go into 1. That means going by 6s. Can you go by 6s and go into 1 without going over 1? So if you look, going by 6s, starting here, the first number is 6, which is already surpassing 1. So no, it is absolutely not possible. 6 cannot go into 1 evenly. Now what I do is I now go over and extend it out. Can 6 go into 12 evenly or get as close to 12 without going over? So how many 6s can go into 12 without going over 12? So I want you to get going by 6s, get as close to 12 as possible without going over. Well, this is not going over, so we're good there. So it at least goes into 1. And look here, it goes in evenly into 6 twice, 2 times. So therefore, 6 can go into 12 2 times without going over. Now that was called dividing. That's what we just did. Now we are going to multiply. Well, what we're going to multiply is going this way around. So you go 2 times 6, which is 12. So you're going to multiply. Now that I put that number underneath, now I'm going to subtract those numbers. 12 minus 12 is 0. Then this means check. What I'm checking for is making sure that number that I just subtracted, before I bring down anything, that number better be smaller than my divisor. If it is not, then I did something wrong up here. So since it is smaller than my divisor, now I can do my next step, which is bring down. Is there a number to bring down? Yes, there is. There is a 6. So I'm going to bring down that 6. And then now that I am done with it, since I brought it down, I must start all over again. Now this is saying, now how many 6s can go into 6 evenly without going over 6? So going by 6s, how many times can 6 go into 6? It can go in 1 time, right into 6. So therefore, you would put the 1 up above here, and then you just multiply again, but now it's 1 times 6, which is 6. And then you subtract, which is 0, and check. You are good. And is there any more numbers to bring down? No. So then you stop. Your answer is 21 to this. So therefore, since it is 21, if you look here, you guys probably with Mr. Brian, he showed you guys an array. When you are doing this, it's telling you in order to find the answer to this, they would say that this is like 126. And the array to this would be doing 21 times by 6. So this is the array that you're going to be seeing. But what they can do to you is they could separate, say, 21, because there is a number in the ones place and a number in the tens place. So over here, what they wanted you to do is to first make an array of 21 by 6, just like this. So if you started here and go and count 1, 2, 3, 4, 5, 6. So from here, this is 6. And then here on over, you want to get 21 of those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that is your 21. So then you're going to make a rectangular array of this. And they want you to see, oh, here's 21. And therefore, they wanted you to see that you could do that. So 21 times 6 does equal 126. So each kid could get one whole row of this, which is 21. So therefore, this could have been, what was his name? Joel could have gotten this row of marbles. Joel could have gotten that. Friend 1 could have gotten this one, this row, and this is friend 2, and then this is friend 3, and friend 4, and friend 5. But they were awfully wordy in trying to show you this. The other thing that they want you to see off of this, that when you multiply these two, it comes out to be 126 inside. So they wanted you to know that, which you guys have known from Mr. Brian. However, the other thing they want you to know is that, say if you did this, you could have separated 21. Now, how could you have separated 21 is by checking each one of these. So separate both the ones place and the tens place. So here it's still a 6. So it's still 6, but you could separate out 21. How could you have done that? Well, how many tens are there? There are 2 tens, which is truly showing 20. And then you could have added just the ones place to equal out 21. So the ones place here is just 1. So what they are trying to tell you is that you could have also separated out 20 plus 1. So this is where I am not a fan, because it's just too wordy to get to one thing. And this is what they really wanted you to show them. And I am not a fan of this. We will go more into making these later on in the year. It's just not time for you to know this yet. So I think it's still too early to show you this. So that is why I'm just going to do a couple of these like this during this Zoom video. However, after that, on your homework, you are not going to be making these. Don't worry about it. You're just going to be finding your division problem and answering it. So what they wanted you to see after you split that up, that you would have done 6 times 20, which is 10 at the end. And then 2 times 6 is what you're left with, which is 12. And then here you would do 1 times 6, which is 6. And so when you add those two, you should come to the realization that it's still going to give you your 126. And that's what they are trying to teach you, but they are so confusing on how to explain this. So I'm not a fan of it. So I just wanted to show you that is just really what they're trying to see. However, I'm just more worried about you finding the answer. And then once you find that answer, I want you to understand that you can do the opposite to check that problem. So here, we found out that the answer to this was 21. So the opposite, the inverse of this would be a multiplication problem. So I wanted you to come up with a multiplication problem using these three numbers to check it to see if you are correct. And what you would have done, or what you could have done, is did this, whatever number is your answer, and then times by 6, or whatever your divisor is. So your answer times by the divisor should equal your dividend. So in this case, you could have worked backwards to show a multiplication. So it would have been 21. Opposite of a division problem is a times, multiplication, 6. And if you did that, you will come out to be 126. And you can always check that off to the side. What is 6 times 1? That's 6. 6 times 2 is 12. And that does give you your answer of 126. So they wanted you to see what was that missing number. It was 21. And then what is the division problem's answer? It's 21. So therefore, your answer should have been 21. So we're going to do lots and lots more. Again, my advice to you first is just find out what the answer is through division, and then you can start filling in these holes. So here is the next problem. It says 52 divided by 4. That is what that problem shows. So 52 goes in the box. Going by 4s, how many 4s will it take to get as close to 5 without going over 5? So now we're going by 4s. So 1 4 is 4, which is still less than 5, which is good. So it could go at least 1 time, but it can't go into 2 times because that went over your 5. So when it comes to dead monkeys smell crazy bad, it only goes in 1 time. Then multiply. 1 times 4 is 4. And then you subtract, which is a 1. Then you check. Yes, it is smaller than my divisor, so I did it right. And then now I checked, I can bring down my next number, which is a 2. So now I start back up at the top. How many 4s can go into 12? Or is close to 12 without going over 12? Well, here it's telling me it can go into 12 evenly, and that is 3 times. So therefore, if you come back over here, it can go into 12 3 times evenly, then multiply it out. 3 times 4 is 12. Subtract with 0 remaining. And checking it, yes, it is smaller. And you are done. Your answer to this array was 13. So in order to find the answer, you could have, so here would have been your division problem, 52 divided by 4 equals 13. But now what you could have done is now worked backwards using a multiplication problem to see if it was true. So the multiplication would have been 13 times 4 equals 52. And you could check that off to the side to see if it is right, if you would like. 13 times 4, that would have been 12, carry your 1. That would have been 4 plus 1 is 5, which is 52. So I just checked my answer. So the answer here is 13. Now the array to this would be 13 by 4 will give you your 52. However, what they are trying to say is that you can also break this 13 apart. So first look at the ones. The ones is a 3. plus what is going to give you 13. Now look at your tens place. There's 110. So 110 is 10. So that's how they're saying that you can separate it and then do it in little chunks. So if you did that here, that would have been a 10, and then this one would have been a 3. So then they're saying if you could have done it this way, 4 times 10 equals your 40. And 4 times what equals your 12? Well, 4 times 3 equals 12. So therefore, the missing numbers here would have been 10 and 3. But they also wanted you to know that you could have also have divided to figure this out. 40 divided by 4 equals what? Because now you're reversing it. This is giving you your answer. You had to have to do a division problem to figure this out. And then if you did, you would have gotten 10. And then 12 divided by 4 equals what? Well, it would have been a 3 there. That's just another way that you could have also looked at it. There are several ways that you can look at this to get the same answer. So that's all that they truly wanted. So therefore, the multiplication sentence that would have fit to finish this would have been a 13 here, and then 52 divided by 4 equals 13 as well. So we're just going to do one more of those array things. So first of all, what I want you to do, just to make this a lot easier on yourself, is know that you are going to first divide this out. I think it's just so much easier just to divide it out, find the answer, and then plug in that number. So it was 72 divided by 4. So going by 4s again, we want to get as close to 7 as possible without going over 7. Well, it can go in once. That is still lower than 7. This is going too high. So therefore, 4 can go into 7 one time without going over. So it can go in one time. So remember, dead monkeys smell crazy bad. So we divide it. It goes in, 4 goes into 7 one time. Now we multiply it. 1 times 4 is 4. We're going to put that right underneath that number. Then we subtract. 7 minus 4 is 3. Then you check it. Is that answer to that smaller than my divisor? Yes, it is. So it is good. Then bring down my next number, which is a 2. Then you start back up at the top. How many 4s can go into 32? So going by 4s, how many 4s can go into 32 or as close to 32 as possible without going over? Your answer would have been 8 times. So it would go in 8 times. So you're going to put an 8 up here. Then 8 times 4 equals 32, and subtract it, and that would be 0. So your answer to this would have been 18. So this would have been 18, and so they wanted you then to show a multiplication problem using these 3 numbers to say the same thing. So they wanted you to do the inverse. So that you could have done the answer times the divisor to equal out this. So you could have said 18 times 4 equals 72, or you could have done the opposite. You could have said 4 times 18 equals 72. So the one that's missing here is 18. So what they wanted you then to know, that when you're making this array, which let me see if it comes out to be 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, it does happen to have all 18 in there. So it would have been a 4 by 18 would be up here. However, what they wanted you to do and to see is that you could have also have separated out 18. So when you separate out 18, you look at its ones, which is 8, plus then separate your tens. There's only one 10, so that would be 110. So 10 plus 8 still gives you 18. So they wanted you to separate this out. So they wanted you to do an 8 plus, sorry, a 10 plus 8. So we'll figure out where that line is drawn. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it separates right here. And then this should be 8 on this side. 1, 2, 3, 4, 5, 6, 7, 8. And it is. Then they want you to say, okay, and this is what Mr. Bryan did with you guys last year, or 4th grade, you probably saw this. It would have been 4 times 10. 4 times 10 is 40. Then you put your addition sign in there. And then what is 4 times 8? That would have been 32. So when you add these two together, you should get your dividend, is what it's truly saying. And what is 40 plus 32? It is 72. Like I said, I don't think you're ready to see the arrays like this all separated out yet. It's still too early, so we will come back to this. So that is why I'm going to adjust what this says, and I'm really just wanting you to work on your division and learn division on this. And then I want you just to then show me multiplication problems that you can come up through that. So I'm going to change up this and what it's saying to do. First, it says use multiplication. Okay, you will be using multiplication. You will be finding multiplication facts. So you're going to use multiplication fact to find this answer in just a minute. But in order to do that, you are not going to be using the distributive property, but I do want you to find the quotient. The quotient means to find the answer to a division problem. So that is what I truly want you to do first. And that's why you're probably confused as to why I numbered it twice, because I want you to find the quotient first. Then it will be easier to find multiplication facts off of those numbers once you divide first. And that is the only thing I want you to do. I do not want you to do distributive property at all. So we are going to first do the division right down here. So whatever is first is always your dividend. So that is 108 that needs to go in the box. This goes on the outside. All right, so now going by sixes. So here's sixes right here. How many sixes can go into 1? Well, it's not possible. It's too small. So what I have my students do is put an X there, saying it's impossible to do. Now, how many sixes can go into 10 without going over 10? Well, here's 1 time, and here's 2 times. 2 times is too large, so therefore it can go only in once. So I just divided, so dead monkeys smell crazy bad. So I just divided. Now I multiply. 1 times 6 is 6. Then you subtract. That would be 10 minus 6 is 4. Check it. That's what the C means. Yes, it is smaller. So now I can bring down my next number, which is an 8. Now going by sixes again, how many times can 6 go into 48 without going over 48? So I'm getting as close to 48 as possible. And this is where, if you know your multiplication facts, this would be a lot faster for you. Here's 48. It goes in evenly. Let's just see how many times it goes in evenly. It goes in evenly 8 times. So then you do 8 times 6 is 48. Subtract it. That would be 0. And you are done with the problem because it went in evenly. So your answer is 18. Now, what I want after you find the quotient, the answer to a division problem, now I want you to now give me 2 multiplication problems off of these 3 numbers only. So again, quotient means answer to a division problem. And then the next thing I want you to do is just give me 2 multiplication facts off of these numbers only. So all you would do is you would just work backwards. You could have said 18 times 6 equals 108, or you could have flipped these around. Remember, commutative property, the commutative property tells you can flip these 2 numbers around and they're still going to give you the exact same. So here are your 2 multiplication facts, and here is your answer. And that's all I want you to do. Don't worry about making arrays. It is very confusing. Just find the answer to the division problem and give me 2 multiplication facts. So here we go. The next thing. This one is 84, so that goes in the box. It's the very first one that's given to you. And then this is 6. So now it's saying, going by 6s, how many times can 6 go into 8 without going over 8? So going by 6s to 8. Oh, it can only go in once, because twice is too much. So again, dead monkeys smell crazy bad. It can only go in once. 1 times 6 is 6. And you subtract, that would be 2. Then you check it. Yes, it is smaller. Good, I am good there. So now I can bring down if there is a number to bring down. And yes, there is a number to bring down. Now that I brought down, then I have to start all over again. How many 6s can go as close to 24 as possible without going over 24? So going by 6s, how close to 24? Oh, it's right here. How many times is that? That is 4 times. So therefore, it goes in 4 times. 4 times 6 is 24. And when you subtract that, that is 0 remaining. So the missing answer here is 14. Now, I want you now to give me the 2 inverse facts with this. The inverse of division is multiplication. So I want you to give me 2 multiplication problems using only these 3 numbers. So you guys could have said 14 times 6, working backwards. Opposite of division is multiplication. 14 times 6 equals 84. Or you could have reversed these and said 6 times 14 equals 84. Next, you're going to do the same thing. Just find the division first. So I'm going to do that up here. So 184. And then this goes in 8. So going by 8s, how many times can an 8 go into 1? Again, this needs to be bigger in order for it to go in at least once. This is too small. It can't go into 1. It's impossible. How many 8s can go into 18? As close to 18 going by 8s without going over. Up, the closest it can get is 16. And how many times is that? That is only twice. So it can go in 2 times. Then 2 times 8 is 16. Then subtract it, and that would be a 2. Check it, we are okay. Then we can bring down, and if you need those things, you can keep writing that off to the side every time. And now how many 8s go into 24? So going by 8s, how close to 24 is possible? Oh, it goes in exactly 3 times. So you're going to come up here. 3 times 8 is 24. Subtract, that would be 0 remaining. Your answer is 23. Now, give me 2 multiplication facts using just these 3 numbers. Again, work backwards. So you could have said 23 times 8, because times is the opposite of division. It equals 184. or you could have used the commutative property saying that you can switch these two around, and that's still giving you 184. All right, so what I want you to do is to do these on your own, 5, 6, and 7. Again, I only want you just to first find the quotient, which is the answer to a division problem. And then the second thing, don't worry about the distributive, give me 2 multiplication facts based off of those. So that is the second thing I want you to do. And that, just like these. So go ahead and pause this, and you can do that on your own, and then we will come back and talk about it. So please pause this and do that. Okay, so you should have paused this, and now I am going to do this very quickly. So when you're going over this to divide, how many 4s can go into 6? So going by 4s, how close to 6 is possible without going over? It was just once. So that would have been 4 times 1 is 4. Then you subtract, that would be a 2. Check it, we are okay. Bring down your 0. How many 4s can go into 20? So now how many 4s can go into 20 without going over? That is 5 of them. So you're going to put a 5 up here. 5 times 4 again using these steps. 5 times 4 now is 20. Then we do smell, which is subtract, and that is 0 remaining with, yes, we're checking and it has nothing remaining and there's nothing to bring down. So our answer is 15 here. So it should have been 15. And the 2 facts that we could have given to multiply would be 15 times 4 equals 60, or you could have said 4 times 15 equals 60. So you could have said this, or you could have reversed them because of the commutative property, and that would have been your answer there. Next, same thing, you should have divided. The first number is your dividend, which always goes in your box, and the second number is your divisor. How many 6s can go into 1? Well, that is way too small, so that can't happen. How many 6s can go into 14 without going over 14? You can go in twice. So that can go in 2 times. 2 times 6 is 12. Then you subtract. 4 minus 2 is 2. Then you check it. Yes, it is smaller, so then I can bring down my next number. How many 6s can go into 24? So going by 6s, how close to 24 is possible without going over? It is 4 times. So then it goes in 4 times. 4 times 6 is 24. Subtract, that would be 0 remaining. Your answer is 24. So what are your multiplication problems that you can come off with on these? You could have said 24 times 6, again, reversing, working backwards, equals 144. Or you could have used the commutative property, which is reversing these 2 and still getting the same answer. So these were the 2 things that you could have said. All right, and then this one, we're going to do this very quick. This is the 9 is the divisor, and then your number is 252. So how many 9s can go into 2? It can't, it's too small. How many 9s, going by 9s, can you go to get into 25 without going over 25? So this is a 9, small. This is getting closer, but still too small. This is too high, so therefore it could only go in twice without going over. So that would have been 18. When you subtract 5, you can't have 5 cookies and give away 8. So you have to come over here, borrow. Now 15 minus 8 is 7. Check it. It is smaller, so now I can bring down my next number. So how many 9s can go into 72? So now go by 9s to as close to 72 as possible without going over. Oh, it goes in exactly 8 times. So then 8 times 9 is 72, and subtract, so your answer is 28. So then I want you to give me 2 multiplication facts using only these 3 numbers. So you could have worked right backwards, which is 28 times 9 equals 252. Or you could have just reversed these. That is the commutative property that allows you to do that. That would be 9 times 28 equals 252. And that is what you can do on your homework tonight as well. All right, next, very quickly, it says they wanted you to find the quotient and then compare. All right, so I'm going to do this super quickly. Going by, so you're going to divide both of these, and we're going to find out what the answers are to these. And this one is 68, and then 4. So let's find out what these answers are. 3 can go into 5. How many times without going over 5? Well, going by 3 is how close without going over 5. It's just 1 time. So once, 1 times 3 is 3. Subtract, that would be a 2. Check, we are smaller. Bring down your next 1. That is how many 3s can go into 21 without going over. So how many 3s go into 21? Oh, there it is. Goes in exactly 7 times. So 7 times 3 is 21 with nothing remaining. So our answer to this is 17. Now we're going to go over here to 4. Going by 4s, how close to 6 can you get without going over 6? Oh, just 1 time. So that can only go in 1 time. Then again, oh, dead, monkeys smell crazy bad if you need those steps. So then it goes in 1 time. So now we multiply. 1 times 4 is 4, and you put that right underneath that number. Then you subtract. That would be 2. Check it. Yes, it is smaller. So now I can bring down if I have anything to bring down, which I do. Now that I brought down, then I start back up at the top. How many 4s now go into 28? So going by 4s, how many times can I go into 28? Oh, there it is. I can put it in 7 times. So I put in 7. 7 times 4 is 28, and that would be 0 remaining. So our answer to this is 17 as well. So they want to know, comparing this, what is going on? Well, they are actually equal to each other. They both have the same quotients. Now I'm going to go over to this one. Still doing the same thing. 252 goes here. Then here I'm going to rewrite this one, 135, and then 3 is my divisor. How many, going by 6s, can 6 go into 2? No, it's too small. How many times can 6 go into 25 without going over 25? So as close to 25 is 24, and that is 4 times. So I'm going to say 4. 4 times 6 is 24. Subtract that. That would be 1. Then check. Yep, it's smaller. Then bring down. Now start all over again. How many 6s can go into 12s? Going by 6s into 12. Oh, it goes in evenly in twice. So this would be 2. 2 times 6 is 12. So your answer to this is 42. Then come over here. Going by 3s, can 3 go into 1? No, still too small. Can 3 go into 13 at least once? Well, yes. Now we have to see how close to 13 is possible. That is 12 is the closest, and that goes in 4 times. 4 times 3 is 12. Then after 1, then check, is it good? Yes. So then bring down number 5. How many 3s go into 15? So how many, going by increase to 15 as possible, that is 5 times. So that would be 5. And 5 times 3 is 15. And subtract. So therefore that would be 45. So what they want you to do now is to see, compare these. Well, 45 is bigger. And remember when you are doing less than or greater than symbols, you want the bigger one to be eaten by Miss Pac-Man or an alligator or however you were taught. So the mouth needs to be pointing to the bigger number. In this case, Miss Pac-Man would want to eat 45 over 42. So therefore, it is the less than symbol. All right, next. Real quick, I'm going to do this again. 5 and then 110. And then this one, 133. And then 7 goes in here. How many 5s can go into 1? Can't do it. 5 can go in. How many 5s can go into 11 without going over 11? So as close to 11 as possible without going over. Well, that is over. So that goes in only twice. So 2 times 5 is 10. Subtract, that would be 1. Check it. We are good. Bring down near 0. How many 5s can go into 10? Oh, we just did that. It was up there. It goes in twice. And that would be 10. Subtract. So therefore, that one would be 22. Next, going by 7s. Can 7 go into 1? No, it's too small. How many 7s can go into 13? Getting as close to 13 as possible without going over. That is going over, so it only goes in once. So that would be 7. Check it. So 13 minus 7 is 6. Check. Yes, it is smaller. Bring down. How many 7s will go into 63? So going by 7s, get as close to 63 as possible. Oh, there it is. That goes in 9 times. So 9 times 7 is 63 with nothing remaining. Your answer to that one is 19. So which one is larger here? That 22 is, so you need Miss Pac-Man's mouth to be eating that. So some people like to use Pac-Man, some people like to use an alligator's mouth. Truly doesn't matter, just make sure that the mouth is open to the larger one. So that would have been the greater than symbol. Now, like I said, it was very, very confusing to do this. So we are not doing that because that is showing just the distributive property to do that, and we are not doing that. Here, you can real quick check the answer to see what needs to be filled in here. So it says Joe collected 45 seashells. He wants to share his seashells among 5 of his friends equally. How many seashells will each friend get? And we are going to find the answer by first dividing. So how many 5s can go into 4? Going by 5s, that is too small. It can't happen. Then going by 5s into 45. So as close to 45 as possible. That is 9 times. So in order to fulfill this, your answer would have been 9. So we should have said 5 times 9 equals 45. And then the division would have been a 9 here. Then they wanted you to do the whole array. So 1, 2, 3, 4, 5. Oh, so this is your 5. So then to make this out, the other one is 9. And you can't separate 9 because it's not 2 digits. So this is your array. 5 times 9 equals 45 of these boxes. So therefore, each kid can get 9 marbles. All right, now I'm going to go into your problems here. Again, I am going to just simply say, I want you to first find the quotient. That means answer to a division problem. That's what I want everyone to do. Answer to the division problem. Again, you can use dead monkeys smell crazy bad. Remember, that is divide first, then multiply, then subtract, then check, then bring down. And then when you bring down something, you must start and repeat all over. So I am going to do a few with you. After you find the quotient first, then the second thing is to find the two multiplication facts. And that is your second thing I want you to do. So I'm changing up the directions. So please make those adjustments. All right, so first thing I want you to do is to find the answer, 96, and then the 6. So going by sixes, how many sixes will go into 9 without going over? It's just once. So we're going to put a 1 here. That would be 6, subtract, that'd be 3. Check it, we are good. Bring down your next number. How many sixes will go into 36? So how many sixes will get into close to 36 as possible? That is right here, which is 6 times. So 6 times 6 is 36 with nothing remaining. So your answer to this was 16. And what are your two multiplication facts? You could have said, worked backwards, and just did work backwards here. You could have said 16 times 6 equals 96, or you could just do the commutative property, which is just flip-flopping these, and said 6 times 16 equals 96. All right, and then I want you to do number 3 for homework. You are not going to do number 4. I'm going to do number 5 with you very quickly. Again, 102 goes in the box, and then the 6 is our divisor. Going by sixes, can 6 go into 1? No, it is too small. Can at least one 6 go into 10? Yes. So now we got to figure out how many 6s without going over 10. It's just 1 time. So 1. And again, you can use your dead monkey smell crazy bad to help you. So it goes in 1 time. So we divided. Now 1 times 6 is 6. So put that underneath that number. 10 minus 6 is 4. Then check it. We are smaller. Then we can bring down. How many 6s now can go into 42? So as close to 42 as possible without going over. Up, it goes evenly into 42 7 times. So 7 times 6 is 42 with nothing remaining. So your answer to this is 17. And then what are your multiplication facts? Again, you can work backwards. You could say 17 times 6 equals 102, or you could also reverse that and do 6 times 17 equals 102. So that is what I want you to do. Again, just finding the quotient and then finding the two facts on that. Here, you are going to do number 6 as well. Again, only doing those two things. Here it says Ken is making a gift bag for a party. He has 64 colored pens and he wants to put the same number in each bag. How many bags will Ken make if he put 4 in each bag? So what you are doing here is this is just simply a division problem. So we're going to do this. So 4 can go into 6 once. That would be 4. When you subtract, that would be a 2. Check it, you are good. Bring down your next number. Going by 4s, how many 4s can go into 24? That is 6 times. So 6 times 4 is 24. Subtract it, that would be 0. Your answer is 16. So therefore, how many bags will Ken make if he puts 4 pens in each bag? And he has 64. Well, 16 bags would be your answer. So I want you to do number 8. Again, this is just finding the quotient. So you don't have to tell me the multiplication facts because that's not what it's asking. Up here it was. Down here it's not. So just find the answer to number 8, which is again a division. Number 9 we're not doing. So then go to the next page. You are not going to do number 1 either. But this one says write an expression. Okay, I'm changing this one up to, so again it says to find the quotient of this. All right, so I am going to do this with you. All right, so we're gonna go ahead and find the quotient. So quotient means finding the answer to division problem. So first, again, use dead monkeys smell crazy bad. So how many 7s can go into 1? You can't, it's too small. How many 7s can go into 12 without going over 12? It can only go in once without going over. So that would be 1. 1 times 7 is 7. Subtract 12 minus 7 is 5. Check it. We are smaller. Bring down your next number. How many 7s can go into 56 without going over 56? Oh, it goes in exactly 8 times. So this is 8. 8 times 7 is 56. So the question just stated, make sure you find the quotient of this. Well, the quotient is the answer to a division problem. So therefore your quotient, your answer, is 18. And that's all they wanted you to do. You didn't even have to do a multiplication fact because it didn't ask you to do that. But if it did ask you how you would check it, be 18 times 7 equals 126, or you could have done 7 times 18 equals 126 as well. The other thing that I want you to do for homework is number 3, number 4, number 5, and number 6. However, on number 6, I am going to change this up because it does say that weird way of saying it. So I'm going to change up the wording, but I do still want you to find the answer to this. It says, what is the value of the 10th of 10 to the 4th power? So I just want you to change up that wording and just answer what is the value of the 10 to the 4th power. So I just want you to tell me the answer to what the 10 to the 4th power is equal to. And that is it. So that is what I want you to do for this lesson today. So once you have all that done, again, please make sure you are learning your multiplication facts. It is going to come into play a lot this year. So start learning on that. And once you have this turned in, you can put this, again, you can show work right on here, and then just give me the pictures or turn it in to the foyer as well if your parents decide to drop it in. So it is completely up to you. I do want to see your work though, so please make sure you are showing your work here. All right, I will see you next time, guys. See you next week. All right, bye.